Lingping, welcome. So excited to have you here and to actually, spend some more time with you. So welcome to the Built for Trust podcast.
Thank you, Nick. It's glad to be here. And by the way, I like your podcast name, Beautiful Trust. That's really nice.
Yeah, awesome, great. Well, thank you. Yeah, it's like we spent some time thinking about it because I think, like right now, a kind of little backstory is that we know that kind of networking and security has been converging, and the only reason to do that is to build infrastructure that you can really trust. That both infrastructure teams can, and also the developers. So anyway, that's
Hi.
kind of a boring, backstory, but that's the backstory.
I like that.
Great.
Trust is the
Uh,
most important asset in anywhere you go. So never go wrong with that.
Yeah, that is for sure. So I'm really interested in learning more about you, Lingping. Like your background, your career choices, because you started off as an operator, and someone who actually built and managed, infrastructure. You don't see a lot of that, in the industry. There's a few companies where that's the case, but not too many. So anyway, tell us a little bit about your career journey.
Sure, Nick. Yes, before I founded Netbrain, man, this is 20 years ago. This is our 20-year anniversary of Netbrain. So we're celebrating that, by the way, with a user conference at Boston. I was
Yeah.
a network engineer.
Congratulations, by the way.
Thank you, Nick. I was a network engineer for 5 years before I founded Netbrain. As you point out, as an operator, I was a first level, second level, and an architect at a company called Thomson Reuters, used to call Thomson Financial out of Boston. Before that, I did a 5 year of mechanical engineering job. But the two jobs really made up my idea of founding Netbrain. Today, we have about over 400 people in 6 countries, and proud to support over 1,000 enterprise and 1/3 of Fortune 500 customer, Fortune 500 companies are customers. So the story of founding Netbrain, a lot of people ask me, when did you come up with the idea? I give them two stories. Typically, Nick, I'll tell you both today. First story is my personal failure. That was 99 that I took a CCIE exam, lab exam, and I failed my first try. That was a big blow to my ego. I worked hard. But I really know network, but I didn't pass the first lab in North Carolina. So I took second one, passed the exam. And I think about it. Wow, these things, there's a lot of in and outs. I could create something, help people to get through the certification, right? Learn the know-how. So that's one side. I have to say that is a trigger point of founding Netbrain. But before, the real reason behind it is probably every network operator care about it, and which I was one of those, is that those all nights. Before the 5 years of work on Thomson Financial, I remember I was an architect, so we were in the second floor. We come to the first floor where a knock is. Every night before I go, I always wave hand, hey, goodbye, guys. I remember one night before I say goodbye, guys, Lingping, there's a problem. Can you come join? So from that to find the problem, it was a whole night. It was a Cisco switch somehow upgraded. They changed the multicasting default from CGMP on to off or off to on. I forgot which way it is, but it took a whole night to figure out that why the multicasting stopped working. And I can remember how many of those all night. Every network engineer probably remember those days, those times. And when you're doing that, something comes to your mind is, just like everything, when network is working, nobody care or ask about it. What is network? But when a network is not working, everybody would know it, right?
Oh my God, yeah.
Right? Think about a recent challenge, all this. Today, but for network engineer, when you are not sitting there whole night trying to figure out an issue, you may not come to your mind. But when you're asking a few basic things. What are my networks made of? This piece, right? What is the baseline look like, right? who made this?
Yeah.
Why? We are not an expert of
Right.
everything, right? I used to work on that network. We always like, why is this configured this way? Is this right or wrong, right? What does the baseline look like? That actually is the other real reason triggering me to start a Netbrain is to have the
Yeah.
knowledge at your fingertip. That I
Yeah.
remember those days when you take a vacation, you always have a pager. You remember those days before cell phone word, right? They were
I
paging you.
do.
And I always
Yeah.
you have to bring a stack of diagrams because you're not going to memorize where the IP is. How do you log into the device, right, to figure it out? And others, and then remember those modem days, right? You get a phone, dial
Yeah.
up to the central, then figure out where the issue is. Those are 99,
Yeah.
2000, 2004.
I remember those times, very, very well, and but those were really great. So kind of like it was kind of not passing the CCIT for the first time. It was the toil of a device that reconfigured itself and trying to figure that out. And then I think it was maybe the third kind of epiphany that you had is that why does this have to be this hard, and it's like when something does break, it breaks hard. It's not so much of a soft break, it just really breaks hard. So not too many people who are running like large corporations like you are right now have that background and have that experience. They might view it, they might understand like the problem, like somebody who's like maybe listening to this right now can kind of relate to it. But when you live through it, it's a very different experience, and especially the toil part of it, when you're with a group of people and you're all smart and it's taking you all night to figure this out. That that's got to be like, it's not just me.
Yeah,
I'm not the one. I'm not like the least bright bulb on the tree. It's like it's all of us who are trying to figure this out,
figuring it
and
out.
we're not getting it. So that basically says that's not an individual's skill set. That's really an industry problem.
Nick,
So that's
I'll tell you a story. When I first joined Thomson, I was young, 30 something, and there was a
mhm,
gentleman 20 years senior of me, and he said, Lingping, I'm going to show you something. So he pulled out a jaw there and point to about half a dozen cable. He said, you know those
mhm,
cables? Each of them
yeah,
took a night to figure it out why this thing is not working. We are how many times we say something is slow? We took a whole organization hours a night to figure out. Oh, okay, that's one of the bad cable. Those are
I
Nick
know.
remind us automation. Remind us what age we are living.
I know it's crazy. So but I want to go back a little bit further.
Mm.
Okay, and so before Thompson, you know, were you born in the States or did you migrate, to the States?
Yeah, I was born in China. I went to
Yeah,
all the way to the college. I grew up in a remote village in China.
yeah,
I until my middle school, I didn't have electricity, so I grew up in front of kerosene lamp. So most of the folks here never smell kerosene. I actually very familiar with that because I went to school, elementary school, middle school, in front of the lamp, the kerosene lamp. Then I finished college at the China and came to the United States for graduate school. And
wow,
for that was 93 to 95. And then worked
yeah,
at a company near my school for 5 years as a mechanical engineer.
yeah. What a great American story. Thanks,
Obviously,
thanks for sharing that. Thanks for sharing that. You can wax poetics around the kerosene lamp and studying. Like as you're describing that, like I can, I just see, a little boy, with a book and a carousel lamp, at night, kind of plowing through
thank you.
the
Yeah.
homework, the week. That's great. Thanks for sharing. Thanks for sharing that story. So
And
that makes it even more potent. It's like you kind of had that experience growing up, and then you come and you start a high tech company up. That's yeah, it's wonderful.
thank you, Nick. And I tell you one little secret is that everywhere I go to antique store, When I see kerosene lamp, I always buy it, bring home. I want to remind my wife. This is she also like me come to here for graduate school, and I point
Yeah.
out this is where I grew up from. With
Well, I'm going to look at kerosene lamps very differently from here on out. So like, all
like,
right. All right. So let's get back to NetBrain. So great. So all right. So we have the problem situated, and really the problem is that it was especially like in the late '90s and even into the early noughts, and frankly, even to this day, it's hard to troubleshoot these systems. Especially when they're large, complex systems and they're multi-vendor, to really understand what is the root cause. And so there's a lot of still toil associated with that troubleshooting and that root cause identification. So I think that's the problem set. So then, all right. So then, how was NetBrain? So what did you think? What would be the way to kind of approach that problem?
yeah, Nick, that's really a good question, but it's also a deep question. We almost live in this world that we handle every problem by know-how, right? At the moment, I separate. I often say to our customer and to my colleague, I said that every problem is solved in the end, right? Big or
Mm,
small. The only difference
yeah,
is how long it take, how many people involved.
yeah,
Remember the Amazon outages and one of the calls saying in the bridge there was over 1,000 people on the bridge trying to solve the Amazon outage, cloud outage.
mm,
Think about that. And we all live in the world that when we have a problem in the phone bridge, 20 people, 30 people, sometimes 100 people on the phone, everyone want to deal with something. So when you're looking at that, you're talking about root cause
mm,
analysis. So what is the issue here? And there's many, but I put together and say, if problem always solved by a human, let's look at what are the people involved and how are they
yeah,
involved in a problem. So I separated these people involved into two groups. One is I call a problem handler, that the people
yeah,
who are digging in front of keyboard, answering questions, figure out, weaving together. And the other group of people are what I call expert, that I build this part, I know this. I build that part, I know that, right? But
yeah.
when we are solving a problem, we don't know which part is to blame. We don't know,
Right.
right? We
Yeah.
have to rely on all this together. So this
I
kind of,
think there's a third. I think there's a third group.
yes, which is,
Yeah. They're the NPCs as well. So it's like they just want to observe,
yes,
because they have a stake in it, and
yeah,
they want to be comforted that something is happening
that's
to
true.
fix it.
That's true. I sometimes
So
call the people breathe on your neck. And
yeah, that's right. Yeah,
want to get an update every 5 minutes, which
yeah,
they also have to report it back. And so the
yeah,
way
yeah,
Netbrain and I create technology, thinking about it is that first of all, how do you create let the two group of people work better together, right?
yeah,
So this is actually very abstract and difficult situation. When I handle a problem, nobody can be expert on everything, right? I need to rely on somebody's expertise, right? I hope it's not real time. In other words, his know-how can be my know-how when I need it, right? This
yeah,
this is to think about like a Google search, right? Used to be I have to go to a library, look at a encyclopedia to figure out some information. Now I can type, boom, information come to me. I don't even need to memorize those things. I just need to be able to process it. So in the world of
yeah,
troubleshooting, we have this. When we're solving an issue, where I often say a slow application, something is slow, people don't realize there's literally 1,000 possibility behind that something is slow. It's not a one problem.
yeah.
It's not a one
Right.
domain, isn't it? Internet.
Mm,
It's multi-vendor, multi-technology, multi-people, multi-expertise. But in the end, it's the people who own. The person who has to handle the problem. There's expert there. How do you bridge the gap on that? This, Nick, I'll tell you, I took an organization, it took 20 years to try to figure this out.
mm,
We went through 4 generations of evolution to try to
yeah,
address this. How do I make people who handling the problem can benefit, leverage the people who is expert on area? That
yeah.
expert might already left the company, right? Might
Right.
already
For
left the company.
sure. Yeah.
Any bigger organization was built by a lot of experts, come and go, right? And the expertise goes with it. So the things we did there, and my first generation did is leveraging the capability, the dynamic map concept. Is if I'm able to put a knowledge into a map quickly, dynamically, so I don't need an expert to prepare. I don't need the end user, the problem handler to find. They can just, based on need, create a dynamic map embedded with all the necessary information for them to be able to reach the next level. That will help.
Yeah.
That's the first 5 years we Netbrain. So we invented the concept of dynamic map, leveraging a data model, digital twin of a complex network. Then, when you need troubleshooting a problem, when you need information, right? Whether you know how multicasting, how BGP works, how VXLAN works, doesn't matter. The information will be there dynamically for you, help you
Yeah.
to gain that expertise, gain that expert access, right? So after that, we found that that's really not enough because a lot of information there, right? You still need a problem handler to be intelligent and smart. So those are our second and third generation that we talk about is how can expert, right, now bring their know-how into automation so that this cannot not just data, but also know-how, how to execute those things. And we went through two generations of technology. One is called runbook-based technology. The other is app-based technology. But this is our next 10 years. It took 10 years to get those two generations right. This is where
That's huge too, because like even like when you're talking, Lingping, the like when you mentioned the AWS outage, and then on the kind of the audio bridge, 1,000 people, you know, there takes a lot of time to get all those people together.
yeah,
Even if it's like 100 people, there is a whole range of communications that go out, and there's a lot of time that's lost just in bringing them together, so that they can, start to address just the problem. And so I don't mean this in the pejorative, but you skipped over that whole thing, and that's a process and a project in and of itself. So what you're doing now is that you're kind of automating getting all of that together,
right.
so that you can actually now start to like work on the problem with at least enough data and now expertise that has been kind of gleaned from people within an organization. And I would think that it's got to span from an application and its entire dependency map, because you don't really know if it's a
Mhm.
networking problem, if it's a cloud problem, if it's a firewall problem, load balancer, wherever it may be there. So that's huge. The amount of I guess mean time to repair should really kind of plummet with that kind of at least you're gathering the data, and you're starting to have a first cut at what could possibly be. And I would imagine all that happens now. If you had a timeline of the same problem, doing it with an old process versus doing this automated process, you would be so far ahead of the game, even before the old process got people onto a bridge.
Right. Even people get onto the bridge because everyone, whether they are expert on this or that, they work on the same level. One of the challenges, they
Yeah,
don't even know what the other people doing. You know, uh, right?
yeah,
Five people might be working on the same thing without knowing the other people doing how to check that. So that Nick bring
yeah,
to us into fourth generation in the 5 years. In the last 5 years, we're
uh-huh.
asking ourselves, saying, when we have the automation, we're now leveraging experts know-how for everyone. But how can we reduce the amount of human involvement? We call it machine-to-machine automation, right?
Yeah.
In
Hmm.
troubleshooting, how can we take people more, even some of them outside of this loop? So we did the fourth generation innovation around this finding root cause troubleshooting. This is actually leveraging two things. One is we call it intent-based automation, the capability to define intent, no code, totally no code. So we found in
Yeah.
the previous third generation, we require people need to know network, but also know some low code capability. But
Yeah.
we're
Hmm.
not everyone grew up as a programmer, myself included. I'm not a programmer. I'm a no coder, right? So And I
Yeah.
want to say, how can we make the export know-how into automation without writing a line of code, right? So that, but this is automation.
Hmm.
Second thing we found that we did that is actually beautiful things with AI, generative AI, especially that when we
Hmm.
have the no-code automation innovation happen, it also still need power user, the expert, tell the problem handler that there is this automation you can use, right? If they don't know, it's still
Hmm.
not going to work, right? And you also need to know if I'm
Mm.
a problem handling, I'm troubleshooting this application issue. It could be a portion was caused by multicasting. The other portion could be caused by routing issue. Yet another maybe SD-WAN. I also needed to know how many automation out there that I can use. You know, that
Yeah.
is actually easy to say than done in real world, right? Automation became part of the fabric, your first thing to go into. So we found that generative AI is a beautiful thing added to the world. That the generative
Yeah.
AI has this capability to weave together automation. I use a word called listen to people. The whole world talking about automation. Internally, we call it listen to your logic. So you say do
Mm.
this, automation turn that human intelligence into machine speed execution. But you have to programmably, logically tell them what do you want to first do this, then do this. If there's a problem, do this. If not a problem, do that. Right? This is logic. You have to be
Yeah.
scientifically defined with automation. With generative AI, you have the capability to listen to expert, use natural language, and
Mm.
then use that natural language, run automation we already built. So now you remove this need for expert to tell the problem handler, oh, I have this automation, you should run this. No, no need anymore. This is, by the way, the generative AI, LLM has this unlimited memory. They can read, 10,000 pages in a second. So they have that. So
Yeah.
we bring these two things together, generative AI and automation together. This is our fourth generation solution. And today it's
Yeah.
really exciting. And Nick, and your audience, if they able to join a user conference which is happening in Boston at the end of this quarter, September 30th to October 2nd, we'll showcase how these things together to help the
Yeah.
troubleshooter. Yeah, it's really exciting.
Yeah, that's awesome. Yeah, yeah, I know that's in Boston. That's like the end of September, October 2nd. Is the
That's right.
user conference. Yeah,
Yes.
that's great. Okay,
Yeah.
so let me ask maybe just a couple of questions on this. So the data gathering. So like all of these devices, and let's we can just focus just on the networking infrastructure.
Sure.
Right now. They all emit a lot of data. There are logs, there are events, telemetry, APIs, lots of different mechanisms to get them. Does NetBrain ingest a lot of that data, and kind of canonicalize it, put it into a standard format so that you can now get state information across the infrastructure?
Mm,
And so, is that like part of what you were referring to around kind of the whole machine learning
mm,
aspect, of the solution? So, in my mind, and I'm not sure if this is your approach, so correct me if I'm wrong, would be the ability to either ingest or just access a large amount of data, mostly log data and telemetry data, from the infrastructure, that you can make some educated assumptions about a particular state of the infrastructure that might be causality towards the problem that you're seeing. And then using Gen AI, with this as well, so you can have, some experts just kind of asking the questions based upon that data. So really kind of guiding Gen AI, to kind of dive more deeper into that. So almost like an assistant, like a co-pilot
mm.
to an expert. So I'm not sure if that's the process, that you've taken, but
Nick, that's a very good description. We took a slight different approach on
okay,
that. One
yep,
approach being done in the past, I have to argue there's a limited success today. Is just taking data like a Splunk type of data, right? Log
right,
file, telemetry data, configure data, and etc. And then providing logic to be able to analyze it, or later even AI, machine learning to read about it, and then to answer, understanding the difference there. And there's a school of the solution like that. We took a different approach on that. One, we
Okay.
do ingest all the data, including the command line data, configure data, telemetry data, and et cetera, et cetera. But we took a different approach by we saying we human knows there is type of problem either happened in the past or as an industry. We turn that
Hmm.
into a capability, a automation to analyze data. And then we allow that capability to be able to replicate itself in the across
Wow.
the network. So we take a human intelligence into automation, then into data analysis piece. So now you think about your network, internally we call it intent, can have 10,000 those little automation analyzer. Okay,
I see.
literally
So
tens of
it's yeah.
100,000 those type of scale,
Okay.
right? Then the generative AI, we use it in a different way. Generative AI can understand human intelligence really well, right? But he doesn't
Hmm.
have is your network's intelligence. Doesn't have the data, doesn't have the capability to process the data. Generative AI is used to weave together the automation that human expertise created, including
Mm.
understanding the experts know-how. Say, do this. So, for example, Nick, if you're troubleshooting multicasting, you might have a five-step things. You can write down the five-step things in a most human-friendly language. Then the generative
Mm.
AI able to use it to guide a Netbrain automation to weave together into an automation. And then
Mm.
when people use it, anytime just typing a question, is my multicasting okay? Right? It will go through the five steps, go through the different group, do all the first hop, do the RP check, do the RPF check, do the last mile check, do the distribution tree type
Mm.
of check. All these things is done weaved together by generative AI. So we took a different approach. We found it's very efficient. Basically, generative
Yeah.
AI along with automation are both learning from people, both leveraging the data that the NetBrain ingested.
Yeah, that's great. So I'm the way I'm kind of processing this, now is that, and I think it makes sense based upon how you organized and thought about NetBrain. It's like looking at workflows and looking at how people now organize themselves to
Right,
solve problems. And so take that into the automation space as well. So having various different, like, maybe problem signatures. You mentioned MPLS. There
mhm,
could be another one about a tromboning issue around a data center. It could be kind of a flapping
sure.
in a data center. It could be a website latency
Mhm.
delay at some level. But so I'm kind of assuming is that you have all these signatures of
Yeah,
these problems that have been pretty well documented across the industry, and then how do we approach those? And
that's
and so you're not boiling the ocean and just trying to like consume all of this data, and then try to like do the needle in the haystack, kind of like process through that. You're more looking at, okay, well, we understand what the problem is, and this is how we would normally troubleshoot that,
right.
and let's automate that process.
Otherwise, like you use the word, there's a signature of different atomic problem, right? In the
Yeah.
troubleshooting word, is a divide concur. You have the if you're going to down to every data, yes, there's unlimited. But if you're going to the knowledge, how many place multicasting can go wrong, what need to be right? You have limited the 30
Yeah.
different atomic piece of it, and you
Yeah.
created that 30 atomic and ask the automation to be able to replicate itself to become its own instance. So he will
Mm.
check for each instance. There's 1,000 different type of check. That's handled by automatically. Now they
Yeah.
weave together. That handled through LLM or through human. If human think the LLM is not a good enough, and you can combine this 10 into a logic using no code capability, right? The atomic automation into no code capability. Then let the LLM handle that. So that beauty of
Yeah.
human intelligence are leveraged both by automation and AI. So the AI
Yeah.
is actually listening, learning from people. Traditionally
Yeah.
machine learning was learned from data, right? You like
Yeah.
talking about oil the ocean, ingested a whole amount of word, and then cannot tell you where did he learn that, right? Also, we don't have good enough data to make a machine learning to enough for them to make it. We took years of research on that, found that's really very difficult to do that, and
Yeah.
also not have data, enough data. The generative AI
Yeah.
indeed changed the conversation.
Yeah, yeah. Well, it's great too because, like, there are colleges don't teach any of this, and you don't. If you go to, like, like the CCI approach or the certification approach, you get to understand one vendor's approach to things, and all of our systems now are multi-vendor, so you have to kind of have a stack of certifications. So yeah, yeah, and everything is really kind of more experiential in our industry and how we kind of solve these problems. So being able to kind of document these, and a process in which troubleshooting does occur based upon a particular signature, yeah, that has a ring of truth to it. That would work. And I'm sure it has. You guys, are in business for 20 years. It's like you got thousands of customers, Fortune 500 companies. Are using NetBrain. Yeah, that's great. That's good. Thank you for sharing, the approach. That's
Nick,
great.
thank you. Our customer really has helped guided us in a way we wouldn't, this wouldn't innovation would not be possible from very beginning. Thomson Reuters, my colleagues, helped me to point out what the problem is. Right, going to later on the
Yeah,
customer like British Telecom, AT&T, where they had managed thousands of networks, they have the needs. Give us this like you describing when you're getting the next level, multi-vendor, every
yeah.
technology detail. So yeah, we're very fortunate to have those customers that really guide us every step along the way.
That's the only way to kind of grow a company. It's like, well, listen to your customers and solve their problems.
Solve
That's
the
for
problem.
sure.
Yeah.
Okay, so then, so you've been focused on kind of network operations. Have you been thinking about security operations or SecOps, as solving some of their problems?
Yes, we actually, most of our customer always have a security in the table from when they decide to deploy NetBrain, own NetBrain. So security is always a component. Although we're not say ourselves focus on security. Security, the raw model, right? You will having those when there's a problem coming, you need to figure out where the attack come from, what is the impact of it, where we can provide immediate value. Is it network related or how network can help to defending any kind of attack? We're providing immediately value there, especially with machine-to-machine automation. In
Yeah.
other words, when you have an attack going on, whether it's through internet, internal, right, and etc., you can use a machine to drive out where the impacted area and figure out how the most efficient way to block some attack, like DDoS attack or DOS attack type of piece. Then going to further is how do you secure infrastructure, right? You got to attack that once, right? And how do you
Mm.
secure it? This is where you want to use automation to figure out those security requirement, define your security requirement, then apply it. Apply it in our word is called replicate, and then enforce it, meaning monitoring it. This is where going to the word of security observability piece of it. We really play a
Mm.
big role there, right? How do you observe your security posture from the static, like CVE, right? You have common
Mhm.
vulnerability exposure. You want to monitor the top tier one, how many exposure you have you fixed or not? And you're going to more deeper security observability piece of it is my internet, my VPN gateway, my key data center ingestion, exchange. Is there any security anomaly that I can observe? So this is where you run automation. Notice the observability is a big word, Nick, that we play a big in that, especially for security, for infrastructure, is because it really requires automation, customized automation. You cannot do it
Yeah.
out of box, right? Because
Yeah.
every company's need on security, every company on application is different.
Well, it's interesting because, like, your approach on the network side of it is somewhat similar to, like, on the security side. Like, they all look for signatures, like, attack vectors and attack signatures, and then that kind of drives a response, a mitigation response. And there is clearly overlap. If there is a DDoS attack, going on, that's a security breach, but that's within the network, and so there's a signature, a
Yes.
clear, signature, for that. But also too is that there could be, like, the signatures that you might be seeing in terms of anomalistic traffic flows and patterns that could be filtered into the security operations team, and maybe that's kind of an early warning sign of like
Hmm.
some kind of a phishing attack that has actually taken hold,
Hmm.
within your organization or what have you. So yeah, so I probably really on the focus of kind of signature identification, and then mitigation against those signatures. There seems to be the kind of the common approach, between
It
NetOps
is.
and security ops.
Nick, your observation is absolutely right. We actually in network we use this special signature called a network intent, which is a signature you define as a template. The difference
Yeah.
there is for network signature to work, you need to replicate itself. You need to figure out how many this signature have 100 instance or 10,000 instance of that, and that instance can then automate,
Yeah.
validate itself, create an early warning, create a validation, continuous monitoring
Mm.
capability. That's our approach. It's very similar. You are right. Except in security world, you can, because the data is general, you don't need to replicate that signature. In network
Yeah.
world, you have to make that signature a specific instance so that
Mm.
that process, so that actually able to help you in troubleshooting, in the change validation, even in the performance trending, we call it a continuous assessment side of it, right? You have a
Yeah.
signature, you know what's your baseline in that particular aspect should look like, whether it's security, application performance, a configure drift, the changes policy, and the compliance, and etc. You have all those footprint signature replicated. Now you can run the observability on top of it. Is there a violation? You can run the diagnosis on top of it. So
Yeah.
yes, Nick, you've described this in a way that are interesting. It is that that how we looking at the complex network world.
Yeah. No, great. I'm learning so much about NetBrain. I'm so glad, about that. So I wanted to kind of focus on like, if we can kind of look out like 3 to 5 years, what do you think kind of the role of NetOps? Let's just focus on NetOps and not the SecOps piece of this, but like, how does NetOps get transformed? So there's maybe a couple of things to consider, right? There's always a shortage of network engineers,
Mhm.
in large numbers. So um, automation is the only way to close that gap. We've always talked about in our industry really more computing and not so much of networking, of kind of lights out operations. So operations kind of like is a regenerative, it fixes itself. It identifies and fixes problems, much like kind of the human system when there is you know um, an illness, that we have. Our immune system attacks it and then mitigates it, and we're fine unless we need pharmacological support.
Mhm.
So maybe what do you see as a future for both for NetOps, like over the next like 3 to 5 years? What does a typical NetOps operation look like?
Yeah, today, Nick, if you look at a NetOps, every company looking at it say, I'm going to move from human-centric to automation-centric, right? Try to use
Hmm.
automation to do as much as it can. And in the future, I would say 3 to 5 years with generative AI and automation, it would be three components in the network ops, right? It would be human components. I absolutely believe humans still going to be a central piece of that. And then there will
Hmm.
be automation piece where the logic, especially important specific network related logic, will be encapsulated into an automation. Then you will have AI components, bigger AI components. AI
Hmm.
components will take away a lot of weaving together automation, a lot of expert knowledge transfer piece of it. But the network operation, in my view, in the next 3 5 years, will not be able to um, without a human, even in the next 5 to 10 years. The human still in the
Yeah.
center, but the change of that is human became more expert, right?
Yeah.
The concept of observing a machine system working. For example, today in a lot of our customer, the biggest things is that human should not touch any problem before automation did its share. And then
Mm.
going further into human will not touch a thing before automation and AI did its share. Now you're going to the next
Yeah.
level. Now, what a human play on this? Human will play the master, will play the expert, that observing the system, tuning up the system, adding their know-how as expert expertise, let automation learn and become automation. Let generative AI take the instruction to learn. And so our NetOps is going to change quite a bit. But it's slow, Nick, is compared to every other thing. It's for a reason, because a lot of folks up there didn't know. I was coming from that environment, knowing that the 30 years of technology has to play together in a network world. So you do not have the luxury like a pure data center. I'm moving to cloud, I'm moving to ACI. Your network board, you have to deal with all. So the capability to have automation layer to deal with all vendor, all technology, whether it's 30 years ago, whether it's last month come out, or the cloud, and have the generative AI or AI technology able to leverage both, it's still a long way to go, but it's exciting. Nick, what I see is the transformation is accelerating, not decelerating, and especially with generative AI. Because before machine learning, it actually tried to do automation doing, and which failed miserably, in my view. Now, the industry probably going towards generative AI and a machine and a human side by side, three components there. That will make things for good, because I think a human want to focus on the things that are really creative, really decision making, how to decide that my traffic pattern should be considered normal. How do I optimize my network so that it's cheaper, it's more efficient, right? And how do I looking at the 2 years later, how do my migration path look like? Instead of my days when I was before I found Netbrain, a good portion of the time I was pulling into troubleshooting, even though I'm designing network. And when that coming, you're dreadful. You figure out why, all night, try to figure out the issues there. And that is now, one of the goal of creating Netbrain is try to remove that burden from human. Our mission statement used to call a democratized automation. The concept of everyone should have automation at their fingertip. Everyone should be able to create automation, without any programming background. It was for this purpose.
Yeah, I love the model, right? So you still have people, you have automation kind of platform, and then you have kind of AI, Gen AI, helping with, kind of helping the human. It's interesting because I think if we think about the staffing component of that, there's a lot of discussion in kind of like AI circles that, whether this is a medical application around doctors or whether it's like lawyers, in the kind of legal field, is that you have obviously a range of skill sets. And so there's a discussion saying that, okay, well, AI could help folks with lower skill sets that are maybe younger and just entering into the industry, or for one reason or the other, just they're not as experienced as others, to upskill them, so that they can become much more effective in their efficacy towards the problem that they're trying to solve increases. So maybe that's also a component here, as well, is that we can have folks who are, just coming into the industry, a couple of years, of experience, and they can be much more effective and much more, potent to problem solving. So that could be like one scenario where the staff doesn't have to be like PhDs, in computer science to kind of like deal with all this. You're really relying upon the automation platform and also the AI pieces to have that kind of the more kind of the I guess the depth, But you still need people, really bright people that understand. Like when you have a BGP problem, in there, that's that's a hard problem to kind of solve, and you need some folks with some real expertise.
I agree, Nick. It's helping the entry level people getting the next level faster, but it also help expert from the top to turn their know-how to everyone. We are expert on BGP, on multicasting, on VXLAN. We don't want to be involved in every BGP troubleshooting, every VXLAN troubleshooting. right? So
That is very true. Yeah.
right? The automation and the
Yeah.
AI actually allow this expert to turn their knowledge into everyone else's knowledge. So organization will be more efficient. The expert is still needed. And I firmly believe 5 years later, machine will not be able to understand all the things, especially within the way network are designed. It's distributed.
Um,
It's many years technology together. You would need a human. Human is very, very important, and there's no way that can be remote. But then human expertise can turn to automation, help other expert, help any other
mhm.
problem operator. That's a big opportunity here. And we see from our customer, and we actually debuting a lot of our customer use case in this user conference, to about how different company, they have a great idea, idea to looking at it. For example, they have this automation that expert set it up, all the auto testing environment. So my
Mm.
network have all this problem happened before, but I want to test this, make sure, test the certain things. I built this 200 auto test. Anytime, any Monday morning, I will see where the change happened in observability dashboard. But I also see my auto test passed or not. If not, did they run the test, right? They should be
Yeah.
aware of the test. And they said, when you have this kind of expert doing a things of company-wide planning, the practitioner focus on those things by benefiting from other experts. So the whole organization became much better, right? In a way, when we moving
Yeah.
this human task into automation centric, we're not taking human out of the loop. Human actually became in the master, in the driver's seat.
Yeah, let me ask this question. So, like, on the business model, like, if you have, experts, from all your customers, and they're, kind of contributing automations to particular signatures, does that get put into the platform for everyone to use, or does that stay within the company?
That's a very good question. It stay with the customer. We call it a private library. So notice
Yeah.
that the know-how, we share some of the know-how, like in a CCIE training, you share how the BGP thing, but the people will always have their unique things. So they build their own. This is in a no-code platform. They build
Hmm.
their own signature. They replicate in their own way. They wrap
Yeah.
around in their own observability dashboard, etc. One is different from the other. For example, if you are consulting, you can use automation to assessment. Your assessment signature is yours. It's actually your intellectual
Yeah.
property, right? It's your intellectual
Hmm.
property. You know how look at the VXLAN in this three angle, and the other company look at it in another angle. We don't have access to that. We don't. We help them to building if they run into advanced issue, but we don't take that. We also don't like a security company pulling out all the security signature to share with everyone. And a network
Yeah.
actually is different. It's a lot of them rely on their design, their policy, their network traffic pattern, right? Their security posture on each of the pattern, each of the signatures. So we don't, the business model point of view, we don't share on that.
Yeah, I can see both ends of that. I can see the argument that, hey, this is our intellectual property. This is our very unique network. This is we're regulated in such a way that drives our policies, and so the applicability of those that automation may not be you know suitable for lots of other organizations other than maybe others in our industry, and we don't want to kind of share that intellectual
Sure.
property with our competitors. So I can see that. I can also see, though, it's that, like, maybe there might be certain signatures that are more broader and that everybody has or has experienced, and that it would be beneficial for everybody, to
Hmm.
have. Like a DDoS attack is, like, just an example,
Hmm.
example of that. Maybe a common VXLAN problem or common misconfiguration,
Hmm.
issue. So anyway, I can see both sides of that, but I think the bottom line is that you've been working with this with all your customers, and that seems to be the model that everyone is comfortable with. So
Yeah.
okay.
Well, we do take both. We share with them some common library. We call it plain vanilla, bottom 5% know-how.
Yeah.
People
Uh-huh.
appreciate it, right? And but the effort of a NetBrain is we try to make a platform easy enough that you don't need a programming skill. actually to be able to build in your own private library, private signature, and
Yeah.
allow your automation be better specific to your network. One of the things, Nick, we did is allow them to do reverse engineer on their network to discover the network design, across it. That we're getting a tremendous amount of reception on that,
Uh,
right?
yeah.
I
I
configure
bet.
the ACL in certain way to make the failover works. I configure the security posture for this application so that it's secure. I configure the QoS. You can reverse engineer those things out of your existing network and make it automation, and that's yours. That's only matters to you,
Yeah.
right? And then your troubleshooting, your diagnosis, your design validation, your continuous assessment can based on this. Your observability can based on what actually your network is made of. So that's the things that
Yeah.
it kind of along the line you're talking about the private library, public library concept.
Yeah, yeah. I think that makes. I think that does make a lot of sense. So, I think it's like if we think about the kind of the future of kind of operations of infrastructure, it's um, we have these three major components that are going to be part of it, and the skill set piece that's really kind of interesting, where we can have experts that are now contributing to the kind of automation libraries for their particular companies, and that both helps upskill others, and then when they leave the organization, which they may at some point in time, their knowledge is still there, to help, and to keep the infrastructure, up and running. And there may also be, and that should also reduce the gap, in terms of the shortage of people that we have in the industry for network engineers. So yeah, Lingping, this has really been great. This has been super, so I think that might be a good place for us to end it,
That's
right?
great. Nick, thank you for the opportunity for me to speak about NetBrain. Yeah,
Oh,
really appreciate that. You're
you're
doing a fabulous job to democratize knowledge about the network for the entire industry. So
uh,
I kudos to you.
uh, oh, well, thank you, Lingping. That's very nice of you to say. So, just for everyone, just remember, so NetBrain has a user conference end of September, October 2nd in Boston. The AI Networking Summit is in Manhattan. NetBrain is going to be there, as well, so you can get to see them in New York as well. So if you're going to the Boston one, just come on up to Boston, or come up to New York, afterwards. And I think that's it. So thanks everyone for watching, and LinkedIn again. Thank you for joining.
Thank you, Nick, for having me. Bye.
Bye.